Okay, so what I'm saying is that Pascal's are you realize that this is how the triangle goes. So when you have a plus b to the power 0, it is 1. Because any number to the power 0 is 1. A plus b to the power 1, you get a plus b. And the coefficient is 1, 1. So here becomes what? 1, 1. That's the coefficient. These are coefficients. Okay. Then you realize that a plus b squared is what? A squared plus 2ab plus b squared. So it becomes 1, 2, 1. And it is 1, 1. So the middle term is this and that. The summation of them, that's 2. And please, the number of terms in every binomial expression is the exponent plus 1. So number of terms, always number of terms is equal to the n, which is the exponent plus 1. So the number of terms is n plus 1. That's the formula. So 0 plus 1 will give you what? 1. So the number of terms is 1. So here 2, if it is 1, 1 plus 1 will give you what? 2. So the number of terms will be 2. So first term, second term. So here the number of terms will be what? 2 plus 1, which is 3. You get it? Good. So when you have this a plus b to the power 3, it becomes a cubed plus 3a squared b plus 3ab squared plus b cubed. And the number of terms, let me write under 1, so 2. So but the number of terms will become 4 because it is 3 plus 1. So the middle terms are the first number here, which is 1 plus 2, which is what? 3. 2 plus 1, which is what? 3. So that's how the triangle goes. So the other one will be 4, 6, 4, 1. The other one will be 1, 5, 10, 10, 5, 1, 1, 6, 15, 20, 15, 6, and 1. Then it goes down. So that's how Pascal deduced his triangle. Okay, but that's not what we are going to use. That's not what we are going to do, because if you know Pascal's, this will give you access to the coefficients. But how do you get the terms? How do you get the actual term? That's the ethic. So listen. So now that you know how to deduce the coefficients, this is how you get the term. The term is very simple. So the first term, okay, let me show you something. This is the coefficients, right? But this is how you get the coefficients using a formula, n combination r. Okay, n combination r, and it is equal to n factorial n minus r factorial r factorial. That's the formula. Okay, this is the formula, but you don't need it because there is a combination on the calculator. Okay, so when you just press 5 combination 0 on the calculator, you should get 5. Is it 5? Hey, sorry, it's 1. It's 1, right? 5 combination 0 is 1. 1, yeah. Then probably 5 combination 1 should be 5, isn't it? It's 5, right? 5 combination 2 should be 10. 5 combination 3 is 10. 5 combination 4, 5. 5 combination 5, 5. I'm sorry, 1. You know how I do it? Because I know the Pascal's triangle of it. You get it? So I just take the coefficients. I know it. So sometimes I don't do these things with calculator. But but there is a but. You may see complex questions that you may demand the use of the calculator or the help of the calculator. So this is how we get the combination. So you don't need, the coefficient. So you don't need the Pascal's triangle because it's archaic. So you just use the combination formula or the calculator, then you get it. Okay, so let's see how we get these ones. So I said it is n combination R, but the combination starts from 0. There are. It starts from 0, okay? Then it ends at the nth term. So the R will start from 0. So if the n is 5, it will be 5. The first term should be 5 combination 0. You get it? The first term should be 5 combination 0. And the last term should be 5 combination what? 5. Okay, so if that's why I said if the combination, the number of terms should be what? N plus 1, because it starts from 0. So 0, 1, 2, 3, 4, 5. That's 6 terms. Okay, so that's how you get to know your number of terms too. So now let's come back to this. If you have a plus b squared or squared, the first term will take the a squared. Okay, always the first term will take the first variable, which is a to the power, the total power. And as it goes on, like, so the second term, the a will reduce by 1, then the b will increase by what? 1. That's the formula. So here a was what? Sorry, the b was 0, a was 2. So a reduced by 1 over a. So it became 2a squared minus 1. Then the b, which was 0, increased by 1. So it's like we borrowed one of the exponents and we gave it to the b so that the b will have existence. And so the third term too, the a increased by what? B decreased. So now that a has fallen by 1, which means a is level 1, and it's decreased by 1, then the b, which has already increased by 1, also increased by an additional 1. That's why it is 2 now. Do you understand? Good. So now let's see. Yeah. A is 3. Because I said always the first term, the first variable takes the maximum power. You get it? So A is 3. So the B is what? 0. But the second term, subsequently, the A will fall by 1, which is 2. Then the B will increase by 1. The A will fall by another 1 from 2 to what? 1. Then the B will increase by 2. By 1, so it will be 1 plus 1, which is 2. Then the B, so the last term, the A will fall because now it's level 1. So it will fall by the 1, then the B will increase by what? 1. So now 2 plus 1 will be what? 3. Do you understand? Good. So that's how we do it. So this is the formula. This aspect is the combination aspect, and that will give you the coefficients. And I taught you that one already. This is the A's aspect of the formula. And this is the B's aspect of the formula. So now let's take it one by one and let's see. Let me clean the side. I don't have. So we are taking it one by one. So I said the R. So here the number of terms will be what? To the power 2, so it will be 3. So 2 plus 1, that's 3. That's the number of terms. So then I told you that R will start from 0 and it will end at the end. So the first term becomes 2 combination 0. Oh, do you get it? Then it will be a to the power n 2 minus what? R, which is what? 0. B to the power 0. That's the first term. Plus the second term. 2 combination, since the first term is 0, the second term will be 1. A to the power 2 minus R, which is 1. B 1, isn't it? And here will be what? 2 combination 2. A 2 minus 2. B 2. So this is the first step. 2 combination 0 is 1 if you use the calculator. 2 minus 0 is what? 0. 2 minus 0 is 2. So 1 times a squared, right? Any number to the power 0 is 1. So 1 times a squared times 1 is what? A squared. Plus 2 combination 1 is what? 2. It's 2. A 2 minus 1 is 1. A to the power 2 minus 1 is 1. Is A, right? Because the 2 minus 1 here will give you 1, and then A. So A. Then the B2 is to the power 1, so it's 1. Then here becomes 2 combination 2 is 1. A 2 minus 2 is 0. And the 0 to the A to the power 0 is what? 1. 1 times B squared will give you what? B squared. So let's try exponent 4. Let's clean them 3. Let's try 4. So 4 becomes 4 combination 0. A to the power 4 minus 0. B 0. That's the first thing. And you know that it should have 5 terms. Okay? So the second term becomes 4 combination 1. A to the power 4 minus 1. B to the power 1. The third term becomes 4 combination 2. A to the power 4 minus 2. B to the power 2. Fourth. 4 combination 4. 3. 4 combination 3. A to the power 4 minus 3. B 3. Then the last term becomes 4 combination 4. A 4 minus 4. B to the power 4. Okay. You understand? Okay. So now you can count, you get 5 terms. Alright. So 4 combination 0 is 1. 1 times 4 minus 0 is 4. So A to the power 4. You know this 2 will give you 1 because B to the power 0 is 1. So here I'll give you A to the power 4 plus 4 combination 1 is 4. 4 minus 1, 3. So A, 3, B, 1. Isn't it? But we don't write the 1. So 4 combination 2 is what? 6. So 6. A, 2 minus 2. 4 minus 2 is 2. Yeah, and the B2 is 2. Plus 4 combination 3 will give you 4. A to the power 1, and we don't write it. B 3 plus the last one will definitely give us 4. A to the power 4 because 4 combination 4 is 0. Is 1. A to the power 4 minus 4 is 0. So A to the power 0 is 1. Then we'll be left with B to the power 4. So this is it, isn't it? This is it. So, okay, this is it. So